What do they all have in common? A smartphone, a fighter jet, an electric car, a supercomputer, an artificial intelligence system, and a modern missile. They all depend on something so small, something so tiny that you could hold billions of them in your hands. Semiconductors, tiny pieces of silicon containing billions of microscopic switches. And yet, these tiny objects have become one of the most important sources of power on Earth. Because whoever controls the most advanced chip doesn't just control technology, they gain advantage in artificial intelligence, in finance, in manufacturing, in communication, and increasingly in war. For decades, the world built one enormous semiconductor supply chain. America designed the chips. Taiwan manufactures most of the advanced ones. The Netherlands built some of the machines needed to manufacture them. Japan supplied critical minerals and components. South Korea became a semiconductor powerhouse. And China became one of the world's largest consumer of chips. It looked efficient. It looked globalized. But there was one problem. The most important parts of this system were concentrated in the hands of few countries. And when the United States and China began fighting for technological dominance, that global supply chain became a battlefield. This is the chip war. To understand this war, forget everything you know about traditional warfare. There are no armies crossing borders, no tanks rolling through cities, no fighter jets filling the sky. Instead, the battlefield looks like this: a clean room, a silicon wafer, and a machine that uses light to draw patterns smaller than human cells. These machines are called lithography systems. They essentially project incredibly precise patterns onto silicons that allow manufacturers to build the microscopic structures that make modern chips work. And this is why semiconductor industries become incredibly complicated. Because no country controls everything. One country may design the chip, another may manufacture it, another may produce the machines used to manufacture it, another may supply the chemicals, another may provide a specialized component. It's a global ecosystem, and for decades, the system worked until geopolitics entered the clean room. The US doesn't dominate the semiconductor supply because American factories produce most of the chips. In fact, much of the manufacturing happens elsewhere. America's advantage is deeper. It sits across some of the most valuable parts of the semiconductor ecosystem: chip design, advanced software, research, intellectual property, and crucial manufacturing technologies. Companies such as Nvidia can design extraordinarily powerful AI processors without physically manufacturing every chip themselves. The design can then be transferred to a specialized foundry. And that's where one company becomes particularly important: the Taiwan Semiconductor Manufacturing Company, TSMC. TSMC helped create a world where companies could design incredibly complex chips without having to own the enormous factories required to run them. That model helped fuel the smartphone revolution, then cloud computing, and now artificial intelligence. But it also created something else: a strategic vulnerability. Because if the world's most advanced chips are essential to the future of AI, then controlling their production becomes a matter of national security. China understood this, and Beijing's ambition wasn't simply to buy more chips. It wanted to become technologically independent. Because China's dependence on foreign semiconductor technology created a dangerous vulnerability. Imagine building your entire economy around the technology while another country controls the tools to produce it. This is essentially the position China found itself in, and Washington saw an opportunity. Starting in 2022, the United States began imposing increasingly aggressive restrictions on China's access to advanced semiconductor and semiconductor manufacturing technology. The logic was simple: if advanced chips are essential to artificial intelligence, and artificial intelligence can strengthen military capabilities, then limiting China's access to the most advanced computing technology will slow China's technological and military rise. But there was a problem with this strategy. The problem was that China could respond, and it did. Instead of simply trying to buy the technology, China began trying to build it. And this brings us to one of the strangest companies in the world, a company most people had never heard of until it became the most strategically important companies on earth: Advanced Semiconductor Materials Lithography (ASML). Based in the Netherlands, ASML doesn't make the chips. It makes the machines that chip manufacturers use to make them. And its most advanced machines use a technology called extreme ultraviolet lithography or EUV. EUV uses light with wavelength of just 13.5 nanometers. That's how advanced chip makers can print some of the incredibly tiny structures required for leading-edge processes. And today, ASML says EUV technology is unique to its system, and that gives one company an extraordinary position. But China has been trying to break this dependence. In July 2026, something significant happened. China began producing its own domestically developed immersion DUV or deep ultraviolet lithography machine. The first machines are expected to be delivered to major Chinese chip makers for testing. They don't currently match ASML's performance, and they are not an alternative to ASML's most advanced EUV systems. But that isn't what makes the development important. The significance is strategic. China is beginning to build its own lithography ecosystem, and that changes the equation. Because Washington's strategy depends partly on controlling technological choke points. China's strategy is to eliminate those choke points. And China isn't stopping at DUV. According to reporting by Reuters, Chinese researchers have also developed an experimental EUV prototype in Shenzhen. The prototype can reportedly generate EUV light, but there's an enormous difference between generating EUV light and building a commercially viable machine capable of reliably manufacturing advanced chips at scale. The gap is enormous. ASML spent more than 2 decades developing EUV technology. The company says it invested more than 6 billion euros in EUV research and development over 17 years. And even today, an ASML EUV system isn't simply one machine. It's an entire ecosystem, thousands of specialized components, ultra-precise optics, lasers, vacuum systems, software, sensors, an enormous network of suppliers. ASML itself describes an ecosystem of around 5,000 partners and suppliers. So China's challenge isn't simply, can we build a lithography machine? The real question is, can China build the entire ecosystem required to compete with the West? And that is a much harder problem. But there's another piece of this puzzle, and it may be the most dangerous one: Taiwan. Because Taiwan isn't simply an island caught between China and the United States, it sits at the center of the world's advanced semiconductor industry. You remember TSMC? It manufactures some of the most advanced chips used by the world's leading technology companies, which means a serious disruption to Taiwan's semiconductor production wouldn't remain a Taiwanese problem. It would become a global economic problem. AI companies, automakers, consumer electronic manufacturers could all face shortages, and the world's technology industry could suddenly discover just how dependent it is on a small island in the Pacific. This is why Taiwan's semiconductor industry is sometimes described as a silicon shield. The idea is that the enormous global importance of Taiwan's chip production creates an economic incentive for the world to prevent conflicts. But here is the uncomfortable question: what happens if that shield fails? This is where the chip war becomes bigger than semiconductors, because the world may be moving towards two competing technological ecosystems, one centered around the United States and its allies, the other increasingly centered around China. The goal on both sides is the same: reduce dependence on the other. America wants to protect its technological lead. China wants to eliminate the vulnerability created by dependence on foreign technology. Every new restriction creates an incentive for China to develop another domestic alternative, while every Chinese breakthrough creates another reason for Washington to tighten controls. It's a feedback loop, and that could shape globalization itself. Because the world once asked, where can we make this product more efficiently? Now countries are increasingly asking, can we afford to depend on someone else for it? And that is a very different world. But there's something else we need to understand. Because even the world's most sophisticated semiconductor industry doesn't exist in isolation. They require specialized materials, specialized chemicals, specialized components, and critical minerals. Which brings us back to where our story began. In our previous episode, we explored the global scramble for minerals that power the modern economy. Now we've seen what happens when those resources are transformed into technology. But there's still one question: what happens when the country with enormous influence over critical minerals also becomes a major competitor in the advanced technology? Because China isn't just trying to build better chips, it's trying to control more of the supply chain that makes those chips possible. And that takes us to the next battlefield: rare earth. Because if the chip war is about controlling the future, the rare earth war is about controlling what the future is made of.